Hello, hello! This is Mr.Samaniego with a special Dojo confession. Now, I have my place value chart, and last time we talked about how easy it is to add using the place value chart. But now, I'm going to show you how easy it is to subtract using the place value chart. And it's pretty much, we're going to be doing the opposite of bundling. Do you remember when we were bundling, if we had 10 ones, if we had 10 ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I had 10 ones, that means that I could bundle those 10 ones. And when I bundled those 10 ones, it gave me 110. And think about it. You have 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those 10 ones make 110. We're going to be doing this the opposite. Same way that you can bundle and move to the left to create a 10-1. You could also decompose. So if you decompose 110, you can move it back up. Move it back over here. 110 equals 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those 10 ones. Okay? Let's practice this. Let's pretend that I have to find the difference between 1,613 and 838. How would I use my place value chart to help me subtract? Well, first I have to put this number right here into my place value chart. I start with my ones. So I have 3 ones. Got 1, 2, 3 ones. I have 110. I have 6 hundreds. 1, 2, 3, 4, 5, 6 hundreds. And I have my 1,000. 1,000. So I have my 1,600, 110, and 3 ones. 1,613. Okay? I need to take away from this number, I have to take away 838. 8 hundreds, 3 tens, 8 ones. Sometimes what I see some students do is that they have this 3 ones and this 8 ones, and they say, well, Mr. Samaniego, the only difference between 3 and 8 is 5. There it is. Easy. And I'm like, wait a second. No. Doesn't work that way. Let's pay close attention to this place value. Here, I have 8 ones, and I need to take away 8 ones from the 3 ones right there. I'm going to put my 3 tens that I need to take away and my 8 hundreds that I need to take away. I take a look and I don't have enough ones to take away 8. So remember, we're going to what it's called decomposing. I know in my head, and you know as well, that 10 ones makes 110. Well, since I don't have 10 ones, I'm going to need to decompose from this 110. I'm going to decompose this 110 and turn it into 10 ones. I'm going to put it right here. And this turns into 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ones. And now do I have enough to take away 8? Yes, I do. Let's take him away. I have 1, 2, 3, 4, 5, 6, 7, 8. I took away 8 once. How many do I have left over? Put a line right this because we're subtracting. How many do I have left over? 1, 2, 3, 4, 5 ones. I have 5 ones left. Next, I need to take away 3 tens from here. I don't have 3 tens to take away. But remember, we can decompose. I'm going to take one of these hundreds because remember, 100 is 10 times as many as 110. So that means that 10 tens makes 100. So I'm going to decompose that 100. When I decompose it, it gives me those 10 tens. Because remember, 10 tens makes that 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I have enough to take away 3 tens. And I will do that right now. Take away 3. 1, 2, 3. How much do I got left over? Let's count them. 1, 2, 3, 4, 5, 6, 7. I got 7 tens left over. Now here, I need to take away 8 hundreds. 1, 2, 3, 4, 5. I don't have enough hundreds to take away. So the same thing, I'm going to decompose one of those thousands to make 10 hundreds. So I'll do that right now. I'm going to decompose. And remember, 1,000 is 10 times as many as 100. So I'm going to put here that 1,000 turns into 10 hundreds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I have enough hundreds to take away 8. And I'm going to count them. 1, 2, 3, 4, 5, 6, 7, 8. There you go. 1, 2, 3, 4, 5, 6, 7, 8. How many hundreds do I have left over? Got 1, 2, 3, 4, 5, 6, 7 hundreds left over. Do I have any thousands? Well, no, because I decomposed it over here. It's not that the 1,000 is gone, it's just it got transferred over here. It got decomposed into smaller units. So my final answer is 1,613 minus 838. It's 775. Now, we're going to do the same thing here in the standard algorithm so you can see the relationship. We're going to start with our ones. Our ones here, I have 3 ones and I need to take away 8 ones. I don't have enough, so I'm going to decompose this 110. So this 110, I move it over here to get 10 ones. So now you have a total of 13 ones. 13 ones, and now I can take away 8 ones. So I'm gonna use my fingers to count 13, and I'm gonna be taking away 13, 12, 11, 10, 9, 8, 7, 6, 5. So I have 5 ones left over. So here, since I decomposed the 110, this is actually a 0 tenths left. Remember how we took away? It's 0 tenths left. I need to take away 3 tenths. I don't have any tenths. So I'm going to decompose this 600 to give me those 10 tenths. So now I have 10 tenths and I'm going to take away 3 tenths. And yes, I can. If I have 10 tenths, take away 3 tenths, I have now 7 tenths. This 6 tenths, when I decompose it, it would turn into 5. The 6 hundredths, when I decompose it, it turned into 5 hundredths. Now, do I have enough hundredths to take away 8? No, I don't. So this 1,000, you know how 1,000 makes 10 hundredths. I'm going to decompose this 1,000 to give me those 10 hundredths. So those 10 hundredths plus that 5 hundredths gives me those 15 hundredths. Can I take away 8 hundredths from 15 hundredths? Yes, I can. So I'm going to count. I got 15 14, 13, 12, 11, 10, 9, 8, 7. I have 7 hundredths left. And you see how using the place value by decomposing, I can subtract large numbers. Same way I do it with the standard algorithm. That was Mr. Samaniego, and this was a Dojo confession.